It's going to say this Hangout on there is live. And this is me practicing and reviewing out loud. F#, domain-driven design, and recently plugging in with emphasis on plugging in C# to an F# domain. So specifically, I started building a WPF application, or a Windows Presentation Foundation application, which is essentially the porting of Nikeza.io to a desktop app, which once I have all my view models fleshed out, which I have about 2 or 3 view models fleshed out, this MVVM, this model view model, I would like to in the future experiment with leveraging the Zamel standard and see if I can port the WPF app to a Xamarin Forms app. That would be nice to do. I could share my screen. I'm just sharing my screen. Yes, come here. Share my screen and present to everyone. Yeah. So I guess I could kill you, and I can. I forgot I installed Visual Studio 2.0 preview. All right, so yeah. All right, so actually, it's Visual Studio 17 preview 2 or something like that. So I'm watching the solution that I have, which this is like domain-driven design made functional. A book that I read that I'm practicing. And it's pretty cool, right? I like this book. It's Domain-Driven Design Made Functional by Scott Vlashin. So I defined 3 bounded contexts: portfolio, profile, and subscriptions. Okay. Those bounded contexts, they pretty much have a makeup of these files: commands, events, query, which makes me think that maybe I should. Everything else is plural. Should I have queries in here? I don't know. Someone tells me I should. Someone tells me I should be consistent with. I have commands, which is plural. I should probably have queries. That's plural as well. And they have this IO that I call try. You have the actual pure domain logic called logic. And you have this workflow. Okay. This logic in here, usually this stuff is like validation. So this logic here takes a this logic here is separated from. This is interesting. I haven't looked at this code before or in a while, but let events that comes from a link result that will. Yeah, I'm not going to look at that right now. All right, so what I said, the title of this video was C# F# interop. Okay. Yeah, I've been going ham in here, so like a lot of this stuff is starting to look foreign to me. Let's focus on the WPF part. So under my integration folder, I have a desktop app. I have a shared library called Nicades in Common. And then I have another library called Nicades.mobile.ui logic, right? So to reiterate, I have a common library and I have a UI logic library. The desktop app, that's the WPF application, and that has all my Zamel files. The UI logic has, well, the user interface logic, or the interaction logic of my presentation with the domain, meaning that the logic dealing with the interaction logic that deals with requests that come from the user interface is in this UI logic library here. Okay. If I launch this application, and it's taking a while to launch. Oh yeah, I have some tests down here too. If I launch this application, then enter your email address. This is like the registration form. Say Scott Nimrod at bizmonger.net, and then I put in password. It says first name, last name. It carried over my email address. So first name I say Scott, last name I say Nimrod. Featured topics, I do F# and I say add. And then I also do I don't know. I have, what else I have in here? Elm. I don't want to do Elm anymore, but I could add that too. Okay. What else is under this combo box? Architecture. And I have a feeling that architecture is not going to look right because I probably need to make the height of this list view larger. Uh-oh. Architecture, add. Yeah, so I can make this list view larger. And then when you save, and you notice the save only gets enabled when you have fields filled out, right? So when you hit save, then it navigates to another page. This page is going to be like the data sources page, where you point to you specify the platforms that your content is on, and you also provide the access ID to access the content on the platforms that you specify. So that's what this page is going to be right here, which isn't really filled out yet. Okay. So far, I have a registration page and I have a this profile editor, right? And all of this is just enough UI to flesh out edge cases that were not yet added for the ViewModel logic that I have. Okay, so that's what I have so far, and so far that logic is based on this profile. Right now, everything is pointing to this profile bounded context. This portfolio and the subscriptions right here, these bounded contexts they're not being used yet, right? That's on my to-do list based on the app that I just demoed. Right now, a registration is relevant to a profile bounded context, and the profile editor is relevant to the profile bounded context. Okay, we see registrations here, and say events, result of executed equal. Okay, yeah. So if we if we isolate this integration folder, I should be able to say scope to this, okay? Then what I have here is I have this shell.xaml file, which only has one element in here that's going to do navigation by means of this frame element, okay? Now, there's different ways to do navigation. So this, right now, this WPF application is a navigation application, which means that based on the UI, it has like this journal of going forwards and backwards, right? And so this is how we leverage that by using this frame. Now, if I drill into the shell.xaml file, then I see that when the constructor is called, the very first thing that I do is I create an instance of a registration page. Okay. Now, if we want to drill into what does that mean? Well, I say registration page equals init registration. If I go to the definition of init registration, you see that the shell.xaml.cs actually expands out into additional files that are under it, specifically this shell.xaml registration .cs. In this file, this is where I handle my implementation details of a XAML file. And also I use the same type of technique to separate the implementation details of my view models as well, usually. Except in this case, my view models are written in an F#, so I'm not able to nest files. Or really, I'm not able to take advantage of partial classes, which is what I'm using. I'm using a combination of partial classes and also file nesting to achieve this, what I would like to say, separation of exposed behavior from the implementation details that the behavior relies on. So in this case, earlier I said that when we call the constructor of the shell, we create an instance of this registration page by means of an init registration method. Okay, this init registration method will actually instantiate the registration page object, and then we assign the data context of the registration page to be this registration view model right here. And then I assign some events. Specifically, this registration has event occurred. And I say, for the event occurred, I want you to do some navigation, right? So I have a method called from registration. This from registration will evaluate what the event was. So the event dot is registered, or is registration succeeded, could be one event. Another event is the event dot is registration failed. Depending on which event it was, I perform navigation. So if the registration succeeded, I say to ProfileEditor, and I pass in the instance of this app frame, and I also forward the event. Same thing here. If the event of the registration failed, then I call to error. I pass in the app frame. I pass in the event. We see that for the to error, we just say navigate to an error page. The to profile editor, that is actually contained in my shell.xaml.profileEditor file that's also nested under this shell.xaml.cs. This to editor will create an instance of a portal page. It should be called profile editor page. So profile editor page like that. It'll create an instance of a profile editor page, and then it'll create an instance of some dependencies that the ViewModel or the data context of the profile editor page relies on. So specifically, it's going to create some dependencies and wrap it into an object for the profile, and also it's going to pass into this dependencies object that I have two functions, right? It's going to inject a function handler. I don't know if I can say a function handler. I guess, well, I'll just say a function. It's going to inject a function for what it means to save a profile, and it's going to inject a function for what it means to get topics, right? So this dependencies that we call inject will inject into the ViewModel a profile of the user and a save function and a get topics function. The save function could, in this case, the save function, because this is the actual application, usually in production, it's going to be a save implementation that performs web requests. The same thing with get topics in production. Both of these functions, and these are functions, right, that I'm passing in. They are going to basically rely on I/O in production. But right now, I just have test data in here. Specifically, I have a test API that's in my UI logic. So I have a mock submit that this dependency is, where am I at? I have a mock save that ultimately reflects this save function, or this save profile right here. And this mock topics is ultimately what this get topics is, right? So this function factory is actually producing the functions that my application will rely on for external system requests. But in this case, because this is all internal right now, I'm mocking out what these functions are. So mock submit, mock save, mock topics, meaning that my application is self-contained, and right now during the development phase of building out this application, I'm not doing any I/O. I'm just handling everything in memory. And so this brings me to one way of doing C#, F# interop, right? So to all these mock functions, such as mock save, these are written in F#. If I go to definition, you see that it's taking me to the DLL definition. But if I say control comma mock save, you're not doing that for me, are you? Okay. So if I go to let me close app. If I go to UI logic, there's a test API that I threw inside here. Here are the mock functions that I set up that the desktop app currently relies on. And as I get this logic fleshed out for the application, then instead of relying on these mock functions, such as mock topics, mock save, mock a failed submit, and mock a submit, these functions will actually be functions that do IO, which will be in my actual domain, which I'm not showing right now. But if I did show it, these functions are actually going to be in these bounded contexts up here when the application is ready to send web requests. But for right now, everything is just going to be in memory and local. So let's go back to my integration folder. So these are the F# functions that I have right here. Okay. Yet my C# or my WPF application that's written in C#, it needs these functions, right? Even though these functions are written in F#. So in order to satisfy that dependency, right? In order for my C# code to use these F# functions, and these are pure functions, they're not methods, they're functions, then what I have to do is I have to basically specify if I want C# to, if I want to call a method in C# that returns a function, then okay, let me start over. If I want a method that's written in C# to return a F# function, then I need to specify a F# func, right? Not just a func that is C#, but an F# func. This F# func will basically have, how do I do this? F# func will have the input that the function requires, in which, in this case, all right, let's talk about our save profile. Our F# func type that our C# code relies on, if it wants to receive a function that's written in F#, we need to specify the input. So F# func that takes as input a validated profile and returns as output, hence this F# results. Returns as output, which is of a result type, a profile request. If it's successful, if the function is successful, if the function is not successful, then the validated profile that we originally provided as input, which is this right here. So, and in order to do that, we pretty much repeat the same function signature. This right here. And we say from converter. And we pass in the F# function. Now, I could do a better job of explaining that, but this is kind of new to me as well. So the more I practice this out loud, the more congruent it's going to sound. So let me try this again. C# code that relies on F# code that returns a function. I think this is called like a high order function or something like that. If C# code wants an actual function to be returned to it, not the result of a function, but the actual function. If C# code wants to retrieve as a result of a request, an actual function in which this function is written in F#, then one technique of accomplishing this is to use a F# func type. This F# func type is going to basically it's going to need the caller, the C# caller, to specify the input of that function that they want, and also the output of the function that they want. And then they can say, based on that F# func type that has the input of that function and the output of that function, from that type they call .from converter, and then they can pass in the actual function name. In this case, mock save is the function name that we want to return, which in my test API is this function right here. So if you notice this function, if I hover over the save function type that it outputs, we see that the save function type that this mock save outputs takes in as input a validated profile and returns as output a result in which if this function was successful or is successful, we'll return a profile, and if it's not successful, a validated profile, which is the input or the argument that we passed into this function. So we go back over here, we see that for the save, a validated profile is the input of the function of this mock save, and the output is a result, right? If we hover over save function, it's a result. But in C# code, we call it an F# results. Okay, when we want to get the results type that's in F#, we call it F# result. Any function written in F# that we want to retrieve, we call it F# func. Okay, so you notice the prefix of F# when you want to do interop with F# code from C# code, we use the F# prefix, and we say function or result. If it's successful, it's profile request. But here we see this just says profile, and that's because the profile type in this result is an alias to profile request. So theoretically, I should be able to do this, and it doesn't like that. KZ.comment.profile. And over here, this profile is, so that's an alias. So we see that this profile here is an, let me go back. This profile here is an alias or a type abbreviation, I think is the name of a profile request, which is why in our C# code we have a profile request, right? Because that's what the actual type is, even though over here we're using, I believe we call this a type abbreviation, which is essentially an alias. Okay. So I discussed our function factory that is written in C# that enables, this is pretty much a class that has various methods, or in this case, they actually are functions, to return functions to our C# client. And this is a ceremony that is required, that I found, in order to return high-level functions to C#. I hope I said that right. All right, so those are the dependencies that I need to inject into my view model for this profile editor page, right? So this is a profile editor page. I instantiate the view model, and I take these dependencies that came from my function factory, which is up here. I throw it inside this inject. In C#, this looks like a class, but in F#, it's actually this dependencies is actually a record type. And so I could show that by going to if I go to home and go to profile editor, where is this at? Or actually, this is under my view model, I think, because that's where it makes sense. So go back here. I'm on the scope to my integration folder, and my profile editor view model will have this dependencies record type right here. But in C#, it appears that C# will view this as a class with parameters. So I have this inject instance, and I pass that as an argument to my profile editor view model constructor. That provides me an instance of the view model. I later attach that view model or that instance of the view model to my profile editor page's data context, which is this right here. In addition to that, this view model exposes a save event. And that save event can be a successful save, or it could be a failure, right? Because in production, this save is going to be a web request. That's the implementation details of what the save ultimately is going to be. And so, because when you rely on I/O, it's not guaranteed to be successful, we have this event, and we have our method handler, or our event handler, called from profile editor, based on this save event of our view model. So this is how we subscribe to the save event of our view model. We pass in the event handler for that, called from profile editor. And from here, that from profile editor will check to see if the profile was saved, or if that save failed. If it was saved, then it calls a toDataSources method, which essentially navigates to the data sources page right there, or it calls toErr, which is right here. It navigates to an error page. Yeah. So that is how I'm doing or building a C# application, specifically Windows Presentation Foundation, that relies on a domain model written in F#. Okay. Now, the view model is written in F# as well, which if I go to definition, then if I go to the definition of the view model, I should be able to collapse this, go to UI logic library, view models folder, and there is going to be a profile editor view model. And so this is what the profile editor page, its data context relies on, is this view model class right here, but this is written in F#. As you see, it takes the dependencies that it needs. Actually, this injected no longer needs this right here. Right, and I should still be able to build, but it's probably a good idea to leave it there. But I don't think this is going to change because, I mean, this is done already. Just need to polish the user interface. I'm building right now since I removed specifying the actual type of the parameter that I have for this view model. Everything succeeds. And so we see that this view model inherits, or this profile editor view model inherits from a view model base. This view model base has the plumbing to do this data binding, this MVVM stuff, right? So specifically, the interface of iNotify property changed. That's what this view model base is handling. And yeah, that's pretty much it. If I go back to this profile editor view model, it exposes, it relies on a couple of events, save event and the topics event. The save event is what I discussed earlier. The topics event is actually the result of requesting topics to feature on your profile, which if you're requesting topics, ultimately you're going to be doing some IO, right? In this case, web requests. And so this topics event basically is going to reflect the event of requesting topics being successful or there being an error when attempting to request topics. And I got some placeholders here for my actual page that I'm rendering, where these are placeholders. So like when I launch the app, you know, it'll say first name, last name, and you type in the edit box of first name and everything goes blank and you put in your actual first name. Same thing with last name. It tells you the data that it wants you to key in. These are my other mutable member variables. These are backing fields for the properties of my view model that my Zamel page relies on by means of MVVM, or by means of data binding. So the Zamel page that I have for the profile editor relies on properties in which these properties are based on these backing fields right here, or these member variables right here. So for example, this profile, this first name, how about that? It's actually, if I do Shift F12, that's the shortcut key for references, and we see that our first name right here, property, is actually relying on this first name backing field for the get and for the set. And then we can modify the first name property when our XAML file, or when our UI changes the value based on a user keying in a different value, right? And it says base class dot notify property changed, and then we call a validate. Right after that, every time they key in data, we want to validate the form to basically decide if the save button on that form should be enabled or disabled based on anytime the user is keying in data. It may be the last required field that they're working on, and so we want to make sure that the save button can be enabled to respond to them finishing the form. So that's what this validate is right here. If I go back, talks about the backing fields. Here's the can save. And this can save is actually being referenced if I do Shift F12. Can save is referenced by this validate right here, this validate command. This validate command, okay, so this validate is a property. No. Well, yeah, this validate is a property that actually points to an instance of a delegate command. A delegate command is, in this case, a class that implements iCommand interface. iCommand interface basically exposes a method called execute and can execute. And so this delegate command, the actual implementation details, is this right here. And basically this is what this is required for data binding and for the model view model architecture when buttons are clicked. And if you're using Prism, I think you can also leverage commands for items control, such as a list view or a combo box. You can also convert, my understanding is you can also leverage commands so that when someone selects an item within items control, that translates to a command that gets routed to our view model that then can have that request forward to our domain logic. So that can save function that we saw earlier, well, that's actually being called on by this validate .execute, which is of type delegate command. And we see here, in order for clients to leverage this validate property right here, we have to expose the interface that we want them to rely on, which is iCommand. And again, the iCommand interface exposes the execute and the can execute. And so there's two clients to this validate property. There's two clients to all these commands that we have in this view model. One is the actual application, the actual Zamel file that represents our user interface, but the other one is also our automated tests over here. They also rely on these commands. So these are two different clients, the automated tests as well as the actual user interface, two different clients. If I run all my tests, everything should still pass. Just because I started talking about tests, I guess I should run them. And everything passes, okay? So those are the commands. These are the properties that my binding relies on, my data binding relies on. Well, not first name placeholder. These are the default values that show up, but the properties are up here. Topics and feature topics and topic, which represents the selected topic from the list of topics that's going to be in the combo box. And the is validated is what our button binds to within this view model. So I'm showing all these different properties, right? But what I haven't showed is the actual Zamel page that relies on these properties. And so that's the ProfileEditor.Zamel, profile editor page. This, where am I at? That's the .ces. Profile editor page.zamel, something like that. So let me kill this window right here. And so this is the actual Zamel page of the profile editor. And there's a couple things in here. I have a converters namespace that I define that actually has a class that implements the I value converter. And I need that when I do data binding to the add button of my profile editor. So when I add a topic, there's an add button, right, for adding the topic. But that button is only enabled if I have a topic that's specified, right? In order to have that topic, which means that I have to have a topic selected from my list of topics in order to add a topic, right? But if I haven't selected a topic, then that add button should not be enabled. Instead, that add button for adding a topic should be disabled because there's no topic selected. So in order to accomplish that, I have, for the button, I have an is enabled property, and I bind that is enabled property to the topic on my view model, okay, which is this right here. This topic represents a selected topic from the user interface that's exposed in the combo box. But that topic is of type string, okay? But the is enabled is of type bool. So a bool is not a string. So in order to accomplish the requirement of, hey, only enable this button if a topic is selected, in which we know a topic is selected if our topic member, which is of type string, has a value, right? And so in order to accomplish that, we use a value converter called nullable to bool converter right here. This nullable to bool converter, if I wonder if it'll let me hit F12 on here to go to definition, is defined right here. And basically there's a convert and convert back. The convert says, if not the value is null, then our enable button should be, or our add button should be enabled, right? So that's pretty much it. Our value converter is not value is null, which essentially means return true for the convert. And true is the type that we need for our is enabled, or a bool, whether it's true or false, is a type that is required to satisfy the data binding for the is enabled property, because is enabled is of type bool. So when we do data binding, regardless of how we get it done, the result of that binding needs to be of a type bool, because that's what our is enabled requires. Our list view right here has a list of featured topics. And then we have a button right here called save, which is right here, okay? In addition, all this is done within a grid, which I have right here. So if you notice the layout, the text box for first name, text box for last name, text box for email, that's all based on grid coordinates. First name is grid.row 0, and it's going to take up 2 columns. Same thing with last name, except its grid.row is 1, email is grid.row 2. They all take up 2 columns. The combo box, however, is in row 3 of the grid, and it's in column 0. The button is in row 3, but it's in column 1, and that's how we have the layout, right? And in addition to that, I have styles that target specific control types, such as button, combo box, list view. And so this is how I did the styles for each of the control types, such as width, height, and margin. And yeah, so to show the profile editor again, and again, all this is written in C#. You enter, this is the registration form, scott@abc.com, 123 for a password. This is the profile editor form that I just went over the Zamel and the view model. Our first name, Scott. Our last name, Nimrod. The test@abc.com. That this value is different because this is coming from our test API, meaning that we mocked out what it means to save a registration. And so that's why this test at abc.com is completely different from the original value that I put in, which was Scott at abc.com on the registration form. And that is essentially what was done in our test API for our, where are we at? The save profile right here, or this sum profile right here. The sum profile is from our mock submit, and that's why we have that value of test at abc.com, because we mocked the submission of a registration form. And that's why we have this value right here. The feature topics is a combo box that's preloaded, right? With some data. So I could say F# or I could say architecture. And now this add button is enabled because I have a topic that is selected from the items control, in which we leverage the value converter that I described earlier in order to say, hey, if there's a topic selected, then let's enable this, but we can only enable it through a value converter that checks to see if there's an instance, right, versus null. That's why this gets enabled. Everything is, all the fields are populated. That's why the save button is enabled. If they weren't populated, then the save button becomes disabled again, right? So there's something I wanted to discuss that I can't remember. Yeah, so that's pretty much it. And if you save, it'll navigate to another page which needs to be fleshed out, which is going to be data sources. Is there anything else I want to share? Our profile editor under desktop app, profile editor code behind has, yeah, so let me show something else. If you notice, if I ABC, I don't know, ABC at abc.com, whatever, 1, 2, 3, 1, 2, 3. You notice that we have placeholders in here, first name, last name, and these placeholders are light gray, right? And if you click in it, in this profile editor page, once you click inside the text box, then the placeholders get removed, and you can type in whatever characters, right? That was accomplished. That could be accomplished in the Zamel, which I prefer to do. But when I was looking into doing everything in the Zamel, some of that Zamel is just as complicated, or shall I say, not as legible to understand. But at the same time, there's a trade-off, right? You can do everything in Zamel, and it will be cumbersome. And you may spend like a significant amount of time trying to figure out the Zamel way of implementing a user experience. And once you get it, like, the stuff usually works. It's all your UX logic is in the Zamel, right? It doesn't leak out into some code behind C# code. So there's some value in that. But also, that Zamel that can be put together based on some required user experience can be very verbose and like not clear on what's trying to be achieved. Of course, it'll be clear to an expert, but to average developers, it may not be as clear, right? And so, my argument would say, well, they need to level up, right? And there's some truth to that. Um, the trade-off is to do it in the code behind, where things may appear to be clearer, so that your normal developers can grasp it. However, the caveat with that is, and I know this from experience, is you have the potential of spending a lot of developer time trying to debug the user experience using C# code. And so you have to manually test all this stuff. And it's just iteration after iteration, like this looping, this feedback loop. And it takes time to launch the application. It takes time to put the application into a testable state by means of navigation and setting values to various controls. So that's what I'm kind of facing right here, right? So like there's a placeholder here, and when I click into it, it does what I expect. If I click off of it, I want it to display the original placeholder, and it's not doing that, right? So those placeholders are lost now. And I mean, I can make it work. It's just, it kind of goes into the reason why I didn't do the Zamel in the first place, is because it was going to be a lot of code. If I did this in Zamel, this stuff would just work. However, I would have to spend some time researching how to do it, which I just wasn't. I didn't feel like it. But that decision bit me in the butt, because I'm facing the same issue again. So I would say I would probably recommend leaning on the side of just doing all your user experience or all your interaction logic in XAML, because stuff it usually just works without having to do all the C# code, manually debug, and like it's just a sucky experience. Anyway, so this is the code behind their interaction logic for the text boxes. So here, actually, that's not what I wanted to show. I wanted to show this right here. This is the code. Our profile editor page.xaml.cs. We initialize the profile editor page with this initialized component. And then we set the foreground, which is the color of our letters, the color of our font, to light gray. We do that immediately for both first name and last name. We don't have to do that for email, because email is supposed to be carried over, so it already has a value. But our first name requires a value. Our last name requires a value. So our placeholder, these fields are going to have a placeholder in it first. So we color it light gray. And then when any of these, when first name or last name receives focus, then we want to basically provide some interaction logic based on the got focus event of those fields. And so we say, first name dot focus response, last name dot focus response, and we pass in our ViewModel, and we pass in our placeholder, right? This placeholder is essentially, in our ViewModel, it's the text that says first name, or the text that says last name, right? That's all it is. We pass that in. And then we also pass in the data context of our control itself, which, yeah, that we don't need this data context field, because we can still get it from this control already. So what I'm saying is, this data context, we don't have to pass in, because we can access it from the control that we're already passing in. And you say, what do you mean? You're not passing in the control. Yes, I am. This is a method extension, right? That C# provides. F# provides the same thing. And so when we go to this focus response, I did not mean to hit F11. I meant to hit F12. Hold up. When we go to this focus response definition, we see that there's a text box parameter that's already provided. Okay. So all I really need to do is say TextBox dot data context as ViewModel, and that's it. And that makes me happy. That should work. If I attempt to build everything, you should work. What's the problem? The focus says, oh, did I? Right here. Right there. This focus response, so this password is the same thing. Call this password box. Say password box dot data context. Like that. It should go over here, and everything should be happy, except we didn't update the password, which is down here. Okay. And if we go back to our, everything should build now. Does everything build? Everything builds. Yeah, so we use a method extension to attach behavior to our text box. So first name has a focus response. Last name has a focus response. We pass in the view model. We pass in a placeholder. That focus response method that we attach to our text box will basically see if the current value of the text box is the compare value that we passed in this case, the placeholder. So I should call that placeholder. I think the password. Okay, fine. Password. You can't put in a placeholder because you don't see text. You just see dots, right? Because it hides the actual values of the text that you put in. But whatever. Actually, this password's not even needed because it can't be used. Like, so if I know this isn't needed, then just delete it, man. And so if I hit Control \E, that will display my errors window. And yeah, it's not needed. Build everything. And everything builds. Now, if I go back to my profile editor page, I discussed the got focus event and how I respond to it. The text change event, I have this input response. This input response will, what does the input response do? This input response will, is this the, input response is different from the focus response. Input response will basically, it ultimately, this is what I care about most, it will change the color of the font. So by default, the color of the font was like light gray, which is this right here, because that's the color of the placeholders that we put there to tell the user what type of data we want them to key in. When the value of that text box is no longer the placeholder value, then the font color is black because now they're keying in actual information. And this logic right here was supposed to be if there's no value, then we need to put in a placeholder again. But there was a funky bug I was running into where, like, if there's no value, we put in a placeholder, and then it would basically, once you start keying in data, it would attach the placeholder text to the data that you're keying in. It just got really messy, and I didn't feel like solving it. So that's it. In conclusion, I think I'll wrap this up. This is C# code in a WPF application that's interoping with F#, with an F# domain. So I'm ending this video. This is me practicing domain modeling make functional out loud, and doing it through a WPF application that I plan to port to a Xamarin Forms application soon. And yeah, so I'm out. If I click in here, I could just type in F#. You know, something I could do is when I key in a value, hit enter, it should map to this add right here button. I need to make this list view longer, meaning I need to modify the height of this list view, and then you just hit save, and then I got to fill out this UI for this page. All right, I'm Scott Nimrod. I'm available for hire. I do desktop application development, which is more enterprise. I do mobile application development, which I prefer enterprise. I do test automation, whether it's unit tests or property-based testing. And I'm really in love with functional programming. It makes me enjoy coding again. And that's it. I'm out here in Miami, but I'm available for hire, and I'm sure we could be flexible and make things work. And also help developers to be more awesome by teaching them how to take responsibility for the code that they write, and write proven code, and actually know how to test their code instead of them being manual testers. They're programmers. They get paid to automate, including the quality controls of the code that they write. I teach them how to do that, but you can only lead a horse to water. They have to want to. They shouldn't have to be told to. That's my message to employers. Adios, te veo a ratito. I'm Scott Nimrod. I'm out. How do I hope I was sharing my screen this time? Yeah. All right, cool. Peace.